Hello everyone, I am Fazla Rabi Abir. Today we will talk about the DLC OBE assignment, and this is also a presentation video. I will explain step by step about my presentation and also assignment. So let's start with the cover page. Here my faculty name is Mr. Nafiz Ahmed Chishti sir, and my section is Q. And here you can see that some alphabets here. So in these alphabets I put my student ID number. Okay, so here for better understanding I put left side the question and put right side in is my assignment basically. And here you can see the B plus F plus H, which is I put my student ID here for maximum car capacity. A maximum car capacity is 14 cars. Here 14 cars. How I found this? From question. Question number 1 answer. This is the block diagram. As you can see the sensor, and then there will be two circumstances. First thing is car will be entering, and then car will be leaving or exiting, and the counter, 4 counter, and compare with 14 cars because of my capacity, maximum capacity is 14 cars. And then the 7 segment display will show two things with a different display or a single display, and that will be, if the parking is full it will be show full. If there is a space, uh, that will show that space available. This is the steps about the block diagram. I already told you these types of steps. This is the flow chart. This is the flow chart basically, and this flow chart is here. You can see the two things: car entering and car exiting. And after that, if entering it will be true, if there is exiting it will be false. After that, compare with the maximum capacity, which is 14, and again it will, if true it will be full, if false it will be space available. And these are the steps for developing this flowchart. System analyzation. The process begins by analyzing the variables. The car count is set to 0 obviously, and the system's maximum capacity is defined 14 cars, 0 to 14 basically. This establishes the baseline for the monitoring system. Okay, executing of the monitoring loop. The system enter a continuous operational loop to monitoring the parking parkings in real time, because if there is a space full, if they're full there will be a problem. Car exit. When a vehicle leaves, the counter performs countdown operation. Capacity check. If there is a 14 cars count, it will be full. If there is less than 14, there will be space available. And continuous cycle. The loop repeats indefinitely, ensuring that every enter and exit is accurate. If there is no accurate, there will be a big problem. This is the 4-bit check flip-flop. For flip-flop, this is the flip-flop. After that, this is also an internal architecture of counter using. This is the 4-bit synchronous up down, and I use this the 4-bit. Question number 2. Second timer. For the second timer, you can see again that the alphabets. How I found this from question. So after that I put my student ID number and then into 2. And here is some lots of calculation parts. First of duty cycle, which is 0.64, frequency 11 hours, and also T, TH and TL I found from frequency, and also duty cycle I found these types of calculation. And then the triple five timer, here you can see the 0.693, which is a fixed value here, and C is the capacitor. I chose the 250 capacitor here. There is a three types of capacitor, which is a 250, 50 and 470. I choose 250 first, then I will choose rest of the options. Here R1 plus 2R2, here's the value, this is the 1, and then 2, then 1 minus 2, we got the R2. Here this is the space available for blinking space. For two types of circuits we need to draw for this question number 2 because of there is a full and also a space available, and this circuit will be in a monostable mode. And I got this circuit, and that was inspired from slide, which is produced by our course teacher also, which is really helpful for us for understanding this type of circuit. This is the circuit, and after that we chose the second one, the capacitor, which is 470. Here 250, 470 and 50. We already chose 250 and now 470 for monostable mode. Here's the circuit, here's the block diagram, and this is the block diagram. We use also a decoder here. We use also decoder and triple five timer also, otherwise it will be not working. So if there is a full and a space available. Here is a question number 3, which is a FSM design. So FSM design, here in question the fixed value is 4. TL and TH and TL fixed value is 4, but in question number 2 we got different things here. TH is 58.24 and TL is 32.76, but here we cannot use this because in question there is a fixed value which is a 4, so we need to use 4 for only for this question. Here after the FSM design, you can see the inputs. There is a P state, N state and the present. After that there will be a 2 output. If there will be a 3 output, it will be drawn like this here, but there is a 2 outputs, and this is a clock reset. Okay, we use 4 ms only for this question. Yeah, state diagram. This is a state diagram here for A and B output, and A and B output value is 4 and the total output is 8. After that, this state diagram, we need to draw a state table. Here's the state diagram basically, and this is the state table. There is a reset, and this is the current state. Always a reset, there will be a first of all 1 and rest of the things will be 0, and this is the current state. This will be across all the time, and how we found this from the state diagram. And this is the next state, and this is the outputs. We got these outputs, A and B outputs here, and we got current states. This value is from our state diagram, and this is the equations of state table. And we found state table, and the final value of output of A and B is A is for PS2 and B is for also PS2, but there was a bar. And this is the final Verilog HDL code, which is if I want, I can code like bigger, but here this little bit of smaller version of Verilog HDL code. Here is the simple thing here. Two input have input wires, that is first of all is clock, and that is the reset, and output will be 2, which is A and B, and assign A, B is the 2, assign B, is to end module here. This is the end of the question number 3, and the final question is basically a theory based question, that there will be no calculation, there will be no coding and everything, and this is totally uh, theory based question. Here question number 4, uh, in identify any drawbacks or limitation for part 1. Obviously there is a lots of limitation current system. So first of all is scaling and display. The hardware counter has a limited capacity and display isn't always active. Yeah, limited capacity, the maximum capacity is 4, which is very low, and in here display always not active. uh, when the output show, the display will show, but not all the time the display is working. So next thing is the lack of precision. It only shows status full or available, space available, rather than the exact number of open spot. If there is a open spot, but uh, how much there is a space available. If there is a space available specifically, they told us it will be a better for user and customers. Fixed hardware, the blinking speed is not adjustable. Propose modification for higher capacity. This is the thing, how we can build this thing for better users. To improve the system for more cars, the following changes are recommended. First of all, MCU integration. A microcontroller replaces multiple logic ICs to simplify the design. Numerical display. Upgrading to display digit displays always allows for an impact exact car count. Digital logic. Using software based counters and advanced sensor provides better accuracy and flexibility. And lastly, we'll talk about the impact of precision change on the system. Efficiency. The MCU handles larger capacities while reducing circuits complexity. Reliable. Software controls ensures more precise and dependable vehicle counting. User friendly. Drivers get a clear exact count of available space. Cheaper and easier. Overall, it will cost less and be simpler to build. So here is the full assignment I explained you. I hope you understand properly. Thanks for your valuable time, Mr. Nafisa Majisti sir, and the students here, my friends and everything. Thank you for everyone for your valuable time. Assalamu alaikum.